All right, welcome to Chapter 11, Section 2, called Measuring Angles and Arcs. This is for Integrated Math 2 or IM2. So a couple things you'll see on your screen here. The first thing you should see is the due date. I don't see it on my teacher preview, but you will see it on your student screen. Number of attempts is always unlimited on homework, tests, and quizzes. The number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever one's the best one you get to keep. And partial credit's enabled, so if you get 1 of 4 questions correct, you get that credit for that one question, but it's also within questions. If there's multiple answers, you can get partial credit within that one question. So please remember, once you start your homework, you must finish it before you can work on anything else. What that means is once you click Start, down here in the bottom right corner, you will see a Submit Assignment button. That is how we finish assignments. You need to make sure that you click the Submit Assignment button when you want to leave this screen. So what it means when it says you can't work on anything else is Alex, the program here, is going to literally freeze your account. So you can't open any other assignments, you can't open resources, everything's going to be frozen until you click Submit Assignment. It's trying to leave this attempt open for you. Remember, you have unlimited attempts, you don't need to leave it open. Go ahead and click that Submit Assignment button as many times as you would like. You can keep coming back and trying over and over again. It's going to save your place, so it's going to know if you've answered the question and click check. If you've gotten a partial response, it's going to let you come back to that. If you've gotten a green check, it's going to stay the green check when you come back in. So don't worry about progress. It's going to save your place. And it will stop the system from locking you out of all of your other features. So huge reason to click that button. The other big reason is that it'll affect the gradebook. So you can see the effect it makes in the gradebook and your teacher can see the effect. Until you click that button, your account is quite literally frozen. All right, so over here we have Explanation, Example, and Message Center. Explanation tells you you're going to lose your question attempt because you're going to get the answer or solution to this question. It's not going to let you come type it in. But Example will show you something very similar to what we're looking at. So this one's going to go through, and define some of the pieces that we need to understand because it's asking us about central angles and semicircles. So we need to know some of these terms in order to answer these questions. So it's going to go through and teach these to us. Once we understand what it wants us to do and what all these terms mean, then we can go through and start answering the questions the way they're showing us to. Make sure you use the arcs. I think they already have these here. If they don't, you need to make sure that you click the buttons to put them in there. You can close this. You can open up another one if you would like. And it'll be a brand new example, or you can message your teacher directly from the screen. It'll attach a picture so we know where to come help you. So I do see the little arc buttons, so I don't have to click on those. So that's definitely nice. Sometimes in the toolbox, it'll actually make you choose those pieces. All right. So over here it says in circle P, in the circle below, P is the center. So we can see P is the center here. QS is a diameter. So it's telling us QS is a diameter. I can see it's going through the center, it's touching the sides, but it's telling us so that we know for sure that that's a diameter, it's not just very close. And then QPR is 50 degrees. So QPR, this angle here is 50 degrees. Use the information to fill in the blanks. So then we go through and it's saying inscribed angle, major arc, minor arc. So we need to know what these pieces mean in order to answer them. So first, they don't actually have central angle in here, but sometimes they do in fact have a central angle. And actually we have to deal with that to deal with the arcs here. So if I come back over here, I'm going to turn my line tool back on. So a central angle is an angle that comes from the center. Hopefully that makes sense. So this is a central angle. And the angle equals the arc. So if this one is 50, or I'll say x in this case, then this guy is also x, okay, for the arcs and the angle. I don't necessarily want to leave that there. I think that might be a little confusing, and I want to make sure that, this is my center. Hopefully that is actually centered. I'm kind of guessing a little bit there. So this is called a central angle because it comes from the center. Whatever the angle is, the arc is also that same degree. So if we know that this angle is 50, the arc it creates from end to end is also 50 degrees. So it's just a relationship there. We don't have to worry too much about that. We have inscribed angles, so I'll do that guy in pink. So inscribed, it goes from side to side. Like it starts over here. We have the same endpoints, kind of like we do with central angle, but it goes all the way to the other side. So this is called an inscribed. Ooh, turn my light tool off. It's only going to let me do so many letters before it starts messing up. Inscribed. angle. So an inscribed angle, if this angle is x, then this is x divided by, times 2. So this is 2x. So if I know the angle, I can multiply by 2 to get the arc. So in this one, the angle, I'm going to actually write it out as this, like I did with the words here. Angle equals, in this case, it would be half the arc, or if you were thinking about it the other way, arc equals 2 times the angle. So you can kind of look at that. It just depends on which one I start with. Means the same thing. If I'm starting with the angle, I'm going to multiply by 2 to get to the arc, the arc out here. If I'm starting with the arc, I'm going to divide by 2 to get to the angle. So it's a little different relationship than the central angle. It's not the same. We have to divide by 2 there. Now we have two pieces. We have major arc and minor arc. So if I'm kind of going back to the central angle, or I could even look at it for the inscribed angle, it doesn't really matter which one. If I'm looking at this one, this is what we would call a minor arc. A lot of the time it's, smaller, minor. A major arc is going to be, and I guess I will do this guy in yellow, the rest, all the way around, like that. So this is the major arc. So these are just some of the terms that they have, so we can identify these pieces. All right, so let's see, give an inscribed angle. So I can see this angle here. I could use this angle S over here. I could actually also use angle T. That would work as well, because the endpoints would just be Q and S. Oh, that's another piece that, because they did have that on the explanation, so I want to make sure I throw this one out there, is a semicircle. So a semicircle is one where it's a diameter and it goes through. So the semicircle would be, oops, darn it, turn the line tool off. I'm just losing my mind here. So this would be a semicircle. Well, man, that's really bad. So a semicircle would be half of the circle. So semicircle, circle equals half the circle. So it's just kind of literally chopped in half like that. So I wanted to throw that out there where they're not actually asking us yet, but we are going to get down here where it's going to ask us a question about a semicircle in just a moment. So I wanted to make sure I define that. All right. So the inscribed angle, we can focus on, a couple of different angles if we wanted to. Like I said, S could work because here's my endpoint T and here's my endpoint Q. Angle T also is an inscribed angle because it's on the side here, but here's the endpoint S and here's the endpoint Q. So either one honestly would work. I'm going to go with S for whatever reason, so I'm going to go angle T, S, Q. Make sure you use 3 letters. If there isn't the kind of numbers inside of here for labels, use 3 letters to identify to make sure that we know which angle that you're talking about. Because sometimes there can be more than one angle. So definitely, use the 3 letters approach there for naming. So give a minor arc. So I could look at this one. I'm going to go QR. Now when I do, sorry, typed it in the wrong one, QR. Now give a major arc. So QR could also be the major arc. When you're doing a major arc, you need to use 3 letters to make sure that the direction is clear. So I could use QTR or QSR, as long as I'm identifying that I'm going kind of all the way around the other side. All right, QR, so this is the central angle. I'm going out to that arc that it creates, so it's going to also be 50 degrees. It's going to be the same. It takes up a 50-degree chunk of the 360 degrees around a circle. And then it says find the measure of QTS. So I have QTS. So this is why I brought in the semicircle idea. So I can see that it's the diameter, and it's going QTS, so it's this arc here. Well, if I chop a circle in half, if we think about going all the way around a circle, so if we go around a circle all the way, that's 360 degrees. If I chop that in half, and I know that's not perfect in half, somewhere like that, and half, then I'm just taking half of the circle, which is 180 degrees. We can also think of a line, if I look at endpoint to endpoint for this chord, it's a line. So it's 180 degrees for that line. That's where we get that idea, actually, of the linear angles 180 degrees. We're actually thinking of a circular model when we say 180 degrees. So it's one of those things we've learned. We're just kind of applying it now to the actual circle. So this guy is 180. All right, check. Next. Okay, the circle below has center K and its radius is 6 meters. Given that the measure of LKM equals 70 degrees, find the length of minor arc LM. So once this minor arc here, and LKM is a central angle. It's coming from the center. Let's see. Give an exact answer in the terms of pi. Oh, haha, it wants the length. I'm going, all it is 70. I'm just losing my crazy mind here. That's what happens when I do too many of these darn videos. So the arc length, this is where we kind of want to step back. We just did circumference. It's a couple of videos ago where we were doing circumference. Might have actually been the last video. So circumference equals 2 pi r, or circumference can equal diameter times pi, because 2r is 1 diameter, right? 2 radii is 1 diameter. So we want to use this, we're going to kind of manipulate it to be a piece of the circle. So I'm going to take this circumference, which would be the entire circle. Well, I only want this small piece of it. So what I'm going to do is take the circumference and multiply it by that piece. So I'm going to multiply it by the degree, so the angle, divided by 360. Why 360? Because that's the entire circle, right? So I still have the 2 pi r, or diameter times pi if I had that. In this case, it's a radius. So here's my original equation, and this is my fractional piece, because it's only a part. So whatever angle they give me, which is 70, divided by 360, this gives me my fraction, the part of the circle I care about. Okay, so I'm going to go 70 over 360 equals 2 pi, not equals, geez, times 2 pi r. All right, and so if I start reducing these, I can divide both by 10, so I get 7 and 36. And it says, give an exact answer. So what they mean by that is they do not want you to do any actual division of 7 and 36. They don't want you to do that part and get a fraction or a decimal that you have to round off. And they also want pi. So we don't want to actually type or use a calculator and hit the pi button. I do want to reduce this a little bit more, because I did actually, instead of r, I should have put in 6 meters, because they told us that was 6 meters. So now I have 2 times 6 times 7, because I can multiply all these pieces together. Remember, these are kind of over 1 in a way. They're all over 1. So 7 times 2 is 14, times 2, or let's see, 14 times 6. I'm going to do this off to the side because I don't want to mess up my silly calculations they're trying to do in my head. So that's 84. So I could have 84 over 36. There is a slightly easier way to do that without multiplying ahead of time. We can do what's called cross-canceling. So hopefully we've all heard of this before. Because 36 is on the bottom, if I have these over 1, 36 divided by 2 is 18. So I can reduce those. And then I can do that again because 18 divided by 6 is 3. So I can reduce that pretty far down. I can actually reduce the 2 and the 6 completely away, which would still have happened if I ended up with the other pieces, but I would have had to reduce the larger number. So now I have 7 over 3, and then pi just gets kind of tacked on there like that. So I'm going to go ahead and go 7 over 3 and then put pi on the end. And I need to make sure that I include my correct unit. This is just the length of the arc, so I'm going to put meters. All right. So below our circles F, C, and J, a central angle of 150 degrees is shown in each. So all of these have the same angle that they're showing us, but we can see that they have different radii. So what we're going to do is we're going to compare the ratio here of circumference and length. So partial lengths anyway. So length of AB, and so we're going to go through and we're going to find the length of AB, we're going to find the length of DE, and we're going to find the length of GH. So we're going to do the same thing 3 times. So I'm going to go over here and I'm going to erase this. Okay. All right, so the length of AB, we're going to have the angle, it's going to be 150 over 36 for each one. This is going to be the same thing because they're all 150 degrees. So, and then times 2 times pi times r. Well, this one's got a radius of 1. So let's see, if we reduce this, we get 15 over 36. And then we can cross cancel, and we'll do that in a different color. 36 divided by 2 is 18. And then 1 doesn't really cancel at all. So I end up with L equals 15 over 18. Ooh, can I reduce again there? I can, because 15 and 18 both divide by 3. So 15 divided by 3 is 5, and 18 divided by 3 is 6. So 5 over 6, and then pi. I don't need to include that 1, because anything multiplied by 1 is itself. So this is the length of AB, this arc here. And then I'm going to go the length of the next piece. And if you notice, the pieces that I reduced are going to be exactly the same. So I'm going to have 150 over 360 times 2. So they're exactly the same. What's going to change is the radii for this one, which I'm going to multiply by 3. So I'm going to end up with this exact same piece here, because these are going to reduce the same way that I did on that last one, like this. So 5, sorry, not 3, divided by 3. So we end up with 5 over 6 because it's exactly the same for this beginning part. What's going to change is, instead of it just being pi on the end, it's going to be, there's still a times 3. So now I need to deal with that piece, because 6 and 3 can cancel out. 6 divided by 3 is 2. So I'm going to put 5 over 2 pi. Let me type these in. 5 over 6. And then I need to make sure I click pi. 5 over, where's my division sign? 2. And pi. Okay. And then, let's see, we have one more. So now we're going to have 2 on the end. So I know it's going to be the same thing. I'm going to end up with 5 over 6 again, but now it's going to be times 2 in the end. So I'm kind of using that pattern to my advantage. I can see that I'm using the exact same numbers over and over again. The only thing that's changing is that number on the end. So I can reduce these. 6 divided by 2 is 3. So now it's going to be 5 over 3 and then pi. All right. So now we're going to look at the ratio, or like the relationship between the length of the arc that we just calculated and the circumference of the circle. So we're kind of, sorry, not circumference, the radius of the circle. I'm just losing my crazy mind here. Okay. So if I look at the length of AB, which was 5 over 6 pi, and I divide that by the radius of the circle, which was 1, well, that's not going to change, right? That's going to stay exactly the same. That doesn't change anything at all, dividing by 1. So it's still going to be pi. The centimeters do cancel, because this has centimeters and this has centimeters, so they do actually cancel off on each other, so we don't have to worry about the centimeters anymore. All right, the next one, if I have DE, so I have 5 over 2 pi, and I divide that by the radius of circle F. Remember, I can't actually divide a fraction by a number. I actually multiply by its reciprocal, like this. So I end up with 5 over 6 pi. Oh my goodness, I ended up with the same thing I did on the last one, didn't I? So I can just copy and paste that guy there. So let's look at the last one. We have 5 over 3 pi, and we would divide by 2. But remember, we can't divide by 2, so we're going to multiply by 1/2. Well, we're going to end up with 5 over 6 again. Pi. So this is actually a relationship we see here. They all have the same relationship. So the ratio suggests which of the following? The length of the arc intercepted by a central angle is proportional to the radius. That makes sense. The length of the arc intercepted by a central angle is 5/6 pi units more than the radius. More than would kind of suggest it's kind of being added. The ratios increased by 5/6 pi units as the radii increased by 1 unit. The ratios increased by 1 unit as the lengths of the intercepted arcs increase by 5/6 pi units, or none of these. So they're just asking us to kind of determine what's the relationship here. And for this guy, it would be that they're going to be a proportional to the radius. So they're just asking us to recognize the idea that nothing changed. Even when we were doing the calculations, I kind of pointed that out a few times. The only thing that changed was the radii calculation. The first part was the same. We had 150 over 360 times 2 times pi. All of that was the same. What changed was the radii. We're multiplying by 1 for this first one. We're multiplying by 3 for the second one. We're multiplying by 2 for the third one. So that was the proportionality. We can see that they are proportional to each other because we can go back, and if I divide each one by its radius, I come back to that exact same ratio. All right. So let's look at this last one. So this one is definitely very useful when we're looking at, say, things that they kind of present to us on the news. Or in articles, any kind of statistical data that they show us. But people love to show pie charts, and understanding the math behind it, to me, is very important because you don't want to see something and not understand why it's misleading. So with this one, it says last week there were 225 student absences at Kennedy High. The table below summarizes them by the day of the week on which they occurred. This information is also presented as a circle graph. So find the central angle measure x for the Tuesday slice in the circle graph. Do not round. So with this one, we're just kind of dividing the circle up. One thing that you should always know is that, if we're looking at percentages, they're giving us just plain numbers and showing us kind of the slice that it takes up. But if you're looking at percentages, they should always add up to 100%. It's one circle, so it's 100% of the circle. You shouldn't get more than 100% or it's misleading. It's not a true graph. If it's less than 100%, it's also misleading because something is missing. So just be aware that, everything should always add up to 100%. With this one, we're just looking at some numbers. We do need to know what the total is in order to complete this. So I need to know the total. They already told us it's 225. So I don't actually need it. I'm just opening the calculator to get ready on this one. So the total is 225. And I want to know what part of the entire circle Tuesday takes up. Looks like it takes up about a quarter. I'm kind of guessing. Or about 25%. So Tuesday, there was 54 absences. So we want to take 54 and divide that by 225. So it was pretty darn close, 0.24. So about a quarter of the circle. That's pretty darn close. So this is, if we converted this to a percentage, this is 24%. So what I want to do here to find the length, if I have 360 degrees, I just want to know, well, what's 24% of 360 degrees? So I'm going to multiply by 360. That'll tell me how many degrees, what the length is, or what the angle is. Sorry, not the length yet, just the angle. So this angle, because it was 24%, the angle is 86.4. So this is the angle. And we're not doing the length. They just asked us what's the central angle. Well, that's going to be the arc length and the central angle. Either way you look at that, it wouldn't matter. So this is, in fact, what they're looking for. We want 86.4 for that slice of the pie. It's an 86. If they asked us now to go through and do the length, for whatever reason, we could. I don't know if that's super useful for a chart like this, but we could go through and find the length if we wanted to at this point. Well, I might be fibbing to you. We would need to know what the radii was, and they haven't told us that, so we couldn't go through and do the length. Ha ha ha. But we can definitely find angle measures using that method. All right, so that was section 2. I will see you in section 3.